Hi. It is time for exam 3 review. And there is no excitement today. It's a difficult day. We all got the email that the summer 2 has been converted to be online only again. So, yeah. There's that hope that we can have at least one normal semester. Exam 3 is going to be on chapter 3. We are going to now discuss the topics, and if you have any questions or problems for me to solve, it's time to ask them now. So that's what we have. So let's go and look at the specifics of the exam 3. So first, let me get my cheat sheet because there are way too many exams and things. I don't want to get anything wrong. So 5-7 through, so that's Thursday through Saturday, noon to noon. Okay. Thursday through Saturday, noon to noon. So 5-7 through 5-9, noon to noon. On Canvas. Exam 3 on chapter 3. That's only 5 sections, but yeah, they're very important. And standard 100 points. 10 problems, and because you guys wanted the extra time and stuff like that, 91 minutes, because you asked for extra time. Maybe you should put, because I did the extra time, maybe I should put 11 problems instead. I might add a problem to make it up to the extra time. So let's see what we have. First, before we go through the list, topics and so on, new syllabus is posted on Canvas. It explains the new grading system for our semester for spring 2020 only. It does tell you about the grade and what happens if you take pass, no credit, and all of that stuff. The pass grade is only for A, B, C, and that's, you can take the pass grade without credit, which means it's not calculated in your GPA. And if you get the pass grade, so again, A, B, C, and you decide to go with the pass grade, it means you guys can sign up for Precalculus1. If you have the grade to be D or F, then you are getting a no credit grade, and the no credit grade has to be retaken next semester or wherever you decide to come back. So that's that. So let's go through the topics. So please read the one important thing is the assignment that replaces your labs. It would be better to have that one assignment that it's a course survey and course final exam review and all of that for 10% of the grade on my MATLAB than to have the 3 labs and then have a no credit final exam review. So please make sure. I already received from one very devoted student. I received the photo of that assignment being already completed at 100%. So woohoo, right? And I said, should we assign another one with more problems? And student said no. So please make sure you go to my MATLAB, get that assignment done. It is open all the way to May 12th, midnight. The sooner you do it, obviously, the more practice you get for the course. All right. So the next order of business for us is to go through the topics for this particular exam, exam 3. We are starting with exponential function. And when I say basics, that means domain plus range, means computing values, means graph with shifts and flips, all that good stuff, means exponential function will have horizontal asymptote. So when we are talking about basics, we are talking about all of these things for any given function. Oh, intercepts. So that's, I think we got everything. All right, then so graphing functions is there and all of that good stuff. The next topic was a logarithmic function basics. And I'm just going to copy all of this and change word horizontal to vertical. So I'm taking all of this. I'm going to say copy. I'm going to go here and say paste. Get out of here. Give me the paste. Thank you. And I'm going to squeeze it in here. There we go. And change the word horizontal to vertical because logarithmic functions have a vertical asymptote. Then I'm going to go into exponential log conversion. So that's the a, b equals c converts into log a, c equals b. We're going to go exponential log inverse, which is technically this as well. But we also have that e to the log, a to the log a of x is x, and log a to the x of a is x. So those are the inverses, but the inverse is also related to what we have up there. So those are the connections between them. We have all log formulas, and we are going to say conversion. It's mentioned up there, but still. We have conversion, we have change of base, so you can calculate and then what else? Change of base, and then the three formulas, which are addition, multiplication, quotient, and power. Let's write it that way. Multiplication, division, power formulas. Those were in 3.3. And then we get to the insane stuff, right? Insanely important stuff. Exponential logarithmic equations. And finally, exponential models, which is word problems. We have growth and decay. So this is the list of topics that are there for our, right. One more time, I see final being mentioned in the in the chat. Those students who take all 3 exams, if they like the average of those 3 exams, they can skip the final, which means they don't take the final, and whatever the average of the 3 exams is will be written in the rubric for the final exam at 30%. So if your average is 82, that's a good average. You don't want to take the final, you might score less than 82 on the final, I don't know. Then you take that 82 by not taking the final, and that will become your final exam grade, and then the course grade will be calculated using that grade. Those of you who take the final will be counted. So even if you took 3 exams and you take the final is counted. Obviously, some of you might have missed an exam. Some of you might have scored very poorly on one of the exams, and you don't want the average of the 3 exams because the final will be better grade because you studied much more and you know much more and so on. Now, I will do everything in my power to give priority to grade your exams prior to the end of the period for the final. So your exam ends on the 9th at noon. Your final begins on the 10th at noon. So that's a 24-hour gap for me to grade. And then you have 3 days, 10th, 11th, and 12th, to take the final. So there will be plenty of time for you to see your exam 3 grade, calculate your own average. Don't email me. Those are the percentages from elementary algebra. So calculate your own average and decide whether you want to take, right, you know your 3 grades there, all 3 will be on Canvas. And then you just say, well, just say to yourself, skipping the final, or if you take the final, then I will count the final. Very simple, right? So no one receives a 0 for the final, right? It's either, because all of you took at least 1 exam, so you might have 10 on the final. I mean, if there's, right, 2 zeros and whatever to average to 10 from 3 exams. So that's it. So I am going to okay, let's take a look at some problems. I am going to ask you to type in the chat anything that you might have as a question. Expanding logs. So now we are going to take a look at a problem which is actually necessary for calculus. Condensing logs is important, so the opposite of the question, right? Condensing logs is needed for your equations. Expanding logs will be used in Calculus 1. So what do we have for expanding logs? Let's say you have a log base 3 of cube root of x, y to the 7 divided by 3z. So that's it. What do we do? We split each one apart, and we have 4 of them. We have 4 factors, 2 are in the numerator and 2 are in the denominator. So all of the factors that were in the numerator will have a plus, and all of the factors in the denominator will have a minus. Therefore, we have log base 3 of cube root of x plus log base 3 of y to the 7 minus log base 3 of 3 minus log base 3 of z. Note that both of these are negative because both of them are in denominator. Now you might say, but no, there was a plus here because it was multiplication. No, it's in the denominator, you get some minus. You can say that these two together are multiplication, but then you have to put them in the parenthesis, and then when you distribute the minus, they will both be negative anyway. So pick your poison, but both of them have to turn negative at the end. Now our job is to get rid of all of the exponents, so 1/3 log 3 of x plus 7 log 3 of y minus 1, because log 3 of 3 is 1, right? When they have the same base and the same number, right? And then finally just log base 3 of z. And this is the expansion for log. Each argument is this thing that goes right inside the log. The same thing like you say argument of the square root, right? Whatever is under the root is called argument. Or sine and cosine, they also have arguments. So each argument has a single variable that it's raised to the first power, linear variable. So that would be considered a problem. Done. All right, let's see. Max, I see you have a question on decay. So do you have a page and a number for your problem? Max? Problem 29. half-life of lead is 22 years. How long will it take for the sample to decay to 80%? There are more words, but we all understand what this question is asking us. So you're starting with some amount of lead. You know, same thing like when you buy a toy from manufactured in China, right? It comes in with a substantial amount of lead in it. And the question is, how long will it take for the lead in that toy to decay, right, to 80% of its original value? Great. Let's see. The formula we use will be mass is equal to initial mass e to the kt. Now we know that the k will be negative because it is a decay problem. We also know that lambda is 22 in this case years, right? You can have minutes and seconds and, you know, hours and so on. We know that in the medical, right, we use hours. So be careful with your units. And now we first use the formula to calculate k, where we take our ln of a half and divide by lambda, and that will calculate the constant k. Now remember, we are supposed to use abacus. 7.1 is the answer. 7.1 years or potatoes. Let's see. I really hope it's correct. So 0.5 divided by our lambda of 22 will give us, so 7.1 hours. No, 7.1 years, right? Because it was supposed to be in years. Okay, good. So let's see. I hope that you have the proposition in the chat is 7.1 years. So hopefully that's the right. All right, negative 0.03. Remember to keep 4 decimals. So that will be 151. 151, right? Because that 0 will be turned into 1 because of the 6. All right, cool. And now I have my exponential model as for lead as this. So this is my exponential model. And the question is, how long will it take to reach 80%? So that's going to be 0.80, which is 80%. You can just call that 0.8 of the original mass, and then original mass e to the lead. When the original mass cancels, right, we have the problem that we need to solve. 0.8 is equal to, leave some space, e to the 0.03151 t. Now, generally what we do is we say ln both sides, because that will kill off e, because of the inverse property that you were supposed to now do this. And now just we have our ln of 0.8 is equal to negative 0.03151 t. So that's our life. And now we're going to see what this calculation gives us. So we have ln of 0.8 divided by negative 0.03151. And yeah, very good. And I like that you use the 1 decimal, because the problem for half-life gives us round value for of 22 years. So 1 decimal is perfect. for this particular answer. Great. So there it is. So that was a decay problem. And I see Paul is asking exactly the same problem with different numbers. So for the second problem, right, this number here is 42. And instead of 0.8 over here, you will be using 95, 0.95. So the question on the half-life for the tranquilizer, and the answer will be in hours rather than years. Can you imagine a tranquilizer that is years? So yeah, there you go. So that problem is exactly the same as this one. You will just change two numbers and follow exact calculations to solve the problem for tranquilizer. All right, cool. So that takes care of the decay problems. If the numbers are not matching in terms of the tranquilizer problems, just make sure that every time when you take ln of a number, you close the parentheses. So this is ln parentheses 0.5 parenthesis closed. Most of your mistakes, guys, in MyMathLab and exams and so on, are the wrong numbers because you didn't close the parenthesis in the calculator. So just make sure that 3.1 hours. Wow, that was a fast calculation right there. Apparently 3.1 hours, I am intend to trust it. Solve the log equation. Very good, very good. There's some variety here. Log base 2 of x minus 5 and then we have plus log base 2 of x minus 2 minus log base 2 of x equals to 2. MyMathLab doesn't register for ln or log. Oh, maybe you have to pick them from the menu. I'm not sure because I don't do homework in this thing. But I know that there is that little equation things that you have to, when you poke into the... I'm logging into MyMathLab to see. Maybe you have to pick them from that list rather than you typing ln on a keyboard, because it might not be recognizing ln from the keyboard. I'm just going to go into random problem in chapter 3.3, let's say. It is the problem with ln's. And now when I click on a box, no. They actually don't have ln as a built-in function. Check maybe capital letters versus lowercase letters. That could be an issue. Or I don't have people generally complaining that it doesn't take ln or a log. So I'm not sure why would that be a case. It seems that since there is no built-in function for it, like there is a built-in function in many of the software out there, there is an issue locally with your computer. That's some kind of feature there. Yeah, it doesn't bold it. And then you're saying as soon as you type it, it should turn it bold. That has to be, call and screen the customer service, see what they come up with. But if it works, if it worked before, and then it stopped, it has to be a local issue. No one else reported it. Okay, let's combine this mess together. And what I see over here are a whole bunch of these logs, and they're all log 2. So I'm going to write this log 2, and I have a division line. I have x minus 5 times x minus 2 on top, single x on the bottom because only one of them is negative, equals to 2. We also have a proposed solution of 10. So let's take a look. But the answer has no solution. Okay, we'll see. So let's go. Well, 10 doesn't work, right? Because it will be 5 times 10. 10 divided by 10 is 1. Log of 1 is 0. Since 0 is not equal to 2. So 10 is definitely not good if I check, right? Think about it. Oh no. It will be 5 times 8 divided by 10. There will be a 4. Log 2 of 4 is 2. Oh, 10 should be good then. Let's see. We'll get there. All right, so we are using conversion. So conversion would be 2 to the 2 is equal to x minus 5, x minus 2 over x. So 4 is equal to, FOIL everything up there, you have x squared minus 7x minus 10 plus 10 divided by x. Cross multiply to get 4x is equal to x squared minus 7x plus 10. And then have x squared minus 11x plus 10 equal to 0, right? When you move 4x this way, it picks up negative 4x. So negative 4, negative 7 is negative 11. It doesn't matter which way you write 0, on this side or the other side, so you just write it on the right. That's what we're used to. Now this puppy factors into x minus 10 and x minus 1, because negative 10 times negative 1 is positive 10, and minus 10 minus 1 is minus 11. So this factoring is good. If you don't know factoring from algebra, then your job is going to be, is going to take longer because you will have to crank through the formula. But this formula will spit out your answers 10 and 1 anyway. So whether you want to do the quadratic or you want to factor it, I don't care, right? Just get it done. So x minus 10 equals 0, that spits out 10. And x minus 1 equals to 0, that spits out 1. And it appears that we have 2 answers, right? So now I need to plug these answers back in the original problem and check what's going on. So I have log base 2 of 5 plus log base 2 of 8 minus log base 2 of 10, supposed to give me the 2. Note that all of the values are positive values, so we are okay to go computing this, right? So that's going to be log base 2 of 40 over 10, which is log 2 of 4, which is equal to 2, so I get to box 10 as good answer, right? Now, for the second value, so that's x equals 10. For x equals to 1, I get log 2, and now I have a 1 minus 5, and that's negative 4. And this is where I don't need to go any further, right? This is log of a negative number, no bueno, right? So we have to throw away, right? As soon as you get to the point where one of the logs, I'm just going to put plus 3 dots, because I'm not going to go and check anything else. I got log of a negative number. The domain for logs is positive numbers only. That's the graph for the log going through 1. So your -4 is somewhere over here. That's not in the domain, right? If you go all the way up and all the way down, it doesn't intersect with the graph for log to produce the y value in the intersection. So we have to throw away 1, keep the 10, move along with our life. So that was a very good example. Anyone else? Oh, so wait. Oh, well, wait. Paul is asking a question, but I don't see a question. I only see the... Oh, there it is. Numbers not in the domain. All right, so here's the Paul's question. Solve it and then hit it with the calculator. 3e to the 5x equals to 1041. I believe I had this problem a couple of years back when I taught Precalculus1. I believe I had this example on the test. Might have been different numbers here and here, but I remember 5x e to the 5x. And I remember being shocked that that was not solved. I mean, obviously not by everyone, but we divide both sides by 3 to get e alone. 3 into 10 goes 3 times, 3 into 14 goes 4 times, and 3 into 21 goes 7 times, so 347. Now, you have option to do the conversion, or you can, what we say, ln both sides. Ln both sides means apply ln to both sides. That will kill off e. So you get your 5x on the left, and on the right side, right, depending on, let me see, solve the following exponential equation for a solution in terms of natural logarithm and common logarithms, then use the calculator to obtain decimal approximation. They do not give us how many decimals they want. So we'll have to be, we're just going to leave one more decimal. So if they don't tell you how many decimals for the final answer, you will leave one more decimals than what the decimals are in your original problem. The problem has no decimals, which means that our answer should have 1 decimal, right? Oh, okay, Paul says 2 decimals. Okay, then we'll provide 2 decimal answer. So we have ln of 347, and that's going to be 5.84932 blah blah blah. Divide that by 5, and the answer is x equal 1.17. Very good. There it is. Confirmation in chat. I am okay with this answer. Now, let's say you're skeptical, as you should be. What do? Well, you check it. What is 3e to the 5 times 1.17 equal to? If it's close to the number, then the answer, you don't need me to bless it, right? Check it. So 3 times e raised to the open parenthesis 5 times 1.17 closed parenthesis, it gives 1041.703 blah blah blah. Yep. That's good. I understand this rounds to 1042, but this is close enough because we had the 2 decimal precision at the answer. With the 4 decimal precision in the answer, remember how I said if they don't tell you, when you do the logs, you take the logs and you keep the 4 decimals, right? Exponential functions grow quickly and they accumulate error quickly. So more decimals, better precision, but then obviously there are more decimals, right? More typing, more opportunities for mistake, more computing power, more everything, right, when you use more decimals. So you want to use as many decimals as necessary. If the problem says 2, you're using 2. If the problem doesn't say anything, then the answer should have only one more decimal than what the problem numbers have, because you can't improve on your precision, because your problem is measured, right? And that's the precision of your measurements. So you can't come up with a 7 decimal answer and your decimals in the measurement were 1. That's pointless. The solution set expressed in logarithms. Okay, so going from this step here, when e5x was equal to 347, you can express this as either log of base e of 347, and because that's equal to 5x, you divide that by 5, or ln of 347 divided by 5. Because, right, that's x equals 2. You can have either of the two sides. So you use the conversion to change your exponential into the log equation, and then you divide both sides by 5 to get x alone. Now, if you just need the answer, then you ln both sides and you cancel off that one. Anything else? Page 490, problem 118. Page 490, problem 118. After how many days all students forgotten the important features of the classroom lecture? How many days? That's measured in milliseconds. What days? Days. That's such an optimistic problem. All right. So for the problem 117 and 118, we are given a decay graph, which is a log-based graph. P of x, so this is 118. P of x is equal to 95 minus 30 log base 2 of x. Measures the percentage P of x of students who recall. So P is the percentage who forgot the important lectures of lesson where x represents the number of days. X measures in number of days. There we go. So after how many days all students forget everything? Well, all students is 100%, right? So all students is equal to 100%. Now, since this is a capital P, they are actually using the 0 to 100 numbers. So we'll plug in 100 is equal to 95 minus 30 log base 2 of x. And now we're supposed to solve this. So this guy is going to go to this side, becomes positive 30 log base 2 of x. And on the right hand side, we have 95 minus 100. So now we have 30 log base 2 of x is equal to negative 5 log base 2 of x is equal to negative 1 over 6 when you divide 30 to both sides. And I believe that should be it, because now 2 raised to the negative 1 over 6 is equal to, why is this coming out to be so weird? Let me just check one more time. 95 minus 30 log base 2. 30 log base 2x. Okay. So how much is this mess? I don't like this. 2 raised to the I get x equals 0.9. 0.9 days? That makes no sense. I really don't like this. So what does it say? After how many days have all the students forgotten the important features of class? Let P of x. Wait, why let P of x 0? Oh, ho, ho, ho. This is how long. Okay, now I get it, guys. I didn't read the graph. I'm sorry. I didn't read the graph. I did it backwards. So, all students is 100%, but they want 100% to forget. Okay? 100% to forget. So that means that this value over here is 0. Because the graph is the percentage P of x is the percentage of remembering. Remembering the lecture. So what I actually calculated of 0.9 days, which is not even a day. So 100% of mentally present students on the class will remember features of that lecture that particular day for whatever 21, 22 hours, right? And then we're going to have people forgetting after that time. That's what I calculated. So now I need to subtract a 0, and I have to redo the problem now. 95 divided by 30, and then go from there to compute the values. So 95 divided by 30 is 3.95 divided by 30, 3.1666, but then we put the 7. That's going to be 2 raised to the 3.1667. To get 9 days. Okay. Well, 8.98, which is 9 days. Good. So within 9 days, all of the students will forget the key features of the lecture. That's why you are supposed to study and practice all the time. This is the reason why people don't do well with math courses in general, right? Because you are required to remember all of algebra and all of pre-calc to be successful in calculus, and then all of the calculus to do differential equations and so on. When we are doing one more decimal than needed, are we still around? Yes. You always look at the first decimal you are throwing away. You always look at that decimal to determine whether the decimal that you are keeping, the last decimal you are keeping, is supposed to stay the same or go by one up. So there we go. All right. There is a pH problem as well for chemistry, so that's something cool. Now, complete the table shown to the right. Can we do one more problem like that? I'm not sure, like what? Like the one with the students remembering and forgetting? Because there's only 117 and 118 in the book regarding that, and you plug in the value. Right. So for 117, it's the same problem of percentage equal to 95 minus log base 2 of x. And they say how many days only half of the students recall, right? So half of the students is 50%. So that will be 50, right? 50 forgets, 50 remembers. And then 95 minus log base 2 of x. So you have your log base 2 of x is equal to 95 minus 50. And that's log base 2 of x is 45. And then when you do the conversion to solve the equation, so we have 95. So this is x equals 2 to the 45. This is not looking good. Log base 2 of x. Oh, I forgot the 30. That's why. There's a 30 over here. I'm looking at these numbers and saying, holy nightmare, it's terrible. There we go. There's a 30 in there. So we still have to divide by 30 on both sides. Perfect. So log base 2 of x is equal to 1.5. And x is equal to 2 to the 1.5. And 2 to the 1.5 is 2.83. So about 3 days for half of the people to forget the concepts and have to remember the concepts. See, the formula was structured around people remembering. So if you want 100% of people forgetting, that's 0 remembering. Now, I didn't read the problem carefully, so I plugged in the wrong number. Instead of 0, I plugged in 100. Now, over here, it's kind of hard to make a mistake. I mean, I did make a mistake because I copied the equation wrong. But hard to make a mistake because when you have 50% people forgetting, then 50% people remember, right? 50%. But these percents can be, right, skewed either way. You can have 60-40 and so on. Just carefully read which one it is and then plug what we need there. Complete the table shown to the right. Well, I don't see any tables anywhere, but what I do see is that population in 2007 was 37.4 million. And projected population in 2044 is 48.2 million. What's K? Okay, we have no problems in figuring this out. We are going to reset our time to 0 in 2007, which will make P0 to be 37.4. So we have population on T is equal to 37.4 e to the kt. Now we need our population point of 244 and 48.2. We need that one to convert to actually the point scaled by t equals 0. So I need to subtract 2007 from here to get my point for, right? So when I subtract this, that's 44 minus 7 is 37.48.2, right? So plug those numbers there and calculate your K instantly. So population will be 48.2, initial population of 37.4, e to the K times 37. So 48.2 divided by 37.4 is equal to e to the 37k, and you have your e to the 37k equal to division of these two numbers, so that's 48.2 divided by 37.4. So that is equal to 1.2888. And then we can, if you want to ln both sides or do the conversion, we don't care, right? Just get it done. So ln of the answer, and then we'll divide. So now 37k is equal to 0.2537. So this is the 4 non-zero decimals divided by 37 to give us the k of 0.00685.6. Here are the 4 non-zero decimals again. So the answer was to find k, and we found k. Now, when you have your k, you can also write the model, right? Our initial was 37.4. E to the 0.00685.6t, and that will be the model, and that will be since 2007. So if you want to calculate 2010, you plug in t equals 3. If you want to calculate, any other value, you would get, yeah. Any other questions, concerns, problems? We did condensing, we did expanding, we did a lot of these word problems. We did decay, we did the growth, we did basic equations where we moved stuff around with these. The only things we didn't do any of the graphing, we didn't do any of the domain, range, asymptotes, we didn't do any of that stuff. All of the answers put as emojis. Can you define? Oh, so I think I understand what Paul is asking. So, guys, y equals ae to the kt is the general growth model with the a as the y-intercept and t as time on x-axis and the y being the right whatever, and that's if your k is larger than 0, and it becomes a decay model like that. Again, you have a as the intercept and all that's good stuff when k is less than 0. Now, for mass decay, you have that mass at any time t is equal to initial mass e to the kt, and because these are generally decay problems, it's a mass decay, then you have the k less than 0, so you will actually be getting something like this. Time, this is the mass of the substance, and this is the initial mass of the substance. So when you are talking about decay of garbage or decay of organic matter, right? So the oil, right, is dead plants and animals, right, from 100,000 years ago and so on. So that's what the oil is. Radioactive decay, garbage decay, plastic decay, cell decay for aging, all of that stuff is this mathematical model here. And simply this means the current mass of the object, this means initial mass of the object, and then decay could be, you have some particles that decay in couple of seconds or so. So these equations are the same equation, except the one with m's is outfitted for exactly for mass decay. Another question. The tablet is getting hot. It's hard to scroll. Another question is page 464, problem 58, which is a graph problem. You were supposed to graph g of x is equal to -2 log base 2 of x. Alright, so if you were taking the normal exam, you would be provided with those boxes, right? And you would be graphing this in stages. Your parenting function or default function or whatever is log base 2 of x, and that one simply graphs as the log that goes through 1. Nothing special there. You have your x and a y. For application, you usually have time t on the x-axis, but now everything is x and a y, right? So that's the log base 2. Now, what are these two transformations going to do to it? Well, the transformation of times 2 is just going to make it rise taller. every y value is going to become twice as tall. So what this is going to do to the problem is it's simply going to make it rise quicker. So what we had earlier to be like this, now it's going to go and do that. So it's not humanly possible to do, amazing job at ×2. As long as it's taller than the previous one, you're good to go, because you're displaying your knowledge that the function is larger, right, taller in y-axis, because, right, that's this y-axis is terrible, so let's just try and do a better job there. There we go. And now you have the minus in front, right? Now this minus is on the entire function, so if the minus is on y, it flips around x-axis. So it will flip on the x-axis, and that flip now, because it's on x-axis, will make the function do this. Now the function still goes through 1 because we did not shift left or right, so it still goes through the same axis, and it's still going to have the go at the same. And but it still passes through x equals 1. Yes, it passes through x equals 1 all the time, because x values are not shifted. In order for this to change, you have to have x plus minus some value in parentheses. That's the only way to change your vertical asymptote and the location through which it passes. So it has to be shifted left or right, right? The plus sign shifts left, the minus sign shifts to the right, and that's it. So it expands after x-intercept. It expands also below. It's very difficult to draw these things because they are all very close. You can go to your calculator, graphing calculator, right? And then graph these two in the same viewing window, and you will see that one is going to be slightly off from the other. So generally these two is not the greatest, for us to test in pre-calculus, because the functions don't have, greatest, it doesn't show very well with the basic functions we do here. Much better situation for you to see this would be when you take trig and you do the amplitude of sine and cosine, which would make the wave twice as big. Then you see it, right? When you draw a sine like this, and then twice the sine like that. So this one was ×1 and this one was ×2. Then it really shines, right? But for these functions, it's not as visible. So it's not one of the good transformations to give to a Precalc1 student. It's amazing transformation for trig, because you can really see it on sine and cosine. Is there anything else? Stream health is orange. Why is it orange? Well, it looks good on bandwidth. I guess it's that time when everyone is going on YouTube. Curfew is starting. So. All right, so if there are no other questions, guys, on Wednesday we are going to have our last lesson of the semester on 7 I believe 4 or 3, whatever. No, 7.4. And I will briefly talk about 7.3, at least to, just make you aware of it. Those of you going eventually in Calc 2. It will be very important for Calc 2 and differential equations. It is optional section 7.3. So we are going to cover 7.4 which is the part of our curriculum. And then for 7.3, I am going to just briefly talk about it, just to be aware, especially for those of you going to Calc 2 eventually, and then maybe differential equations if you are an engineer or something. Physics, math, degree, and so on. Make sure you are there on Wednesday. Exam will be Thursday through Saturday, and then Sunday through Tuesday, final exam. Make sure you do the course survey, which is technically the same thing like homework, except it contains all sections from the beginning of the semester. Make sure you score 100 on that one, because it counts as 10% of your grade. For the course, we do not have labs now, and this replaces that. So make sure you finish all of that stuff. And that's it. So I'll talk to you guys on Wednesday. Bye.